All right, statistics, here we go. We're going to finish off section 5, 6. So much going on in this chapter. Okay, so we were talking about the normal curve. I should probably draw the normal curve on this, I'm assuming. Let me get caught up in my notes here. Nope, that's not right. Okay, there we go. I'm going to draw a normal curve on here. You guys were supposed to do some work here last night, weren't you? So let me go back and fill this in. Number 2, just so you know, should have been 95%. Number 4 should have been 81.5%. Number 6 should have been 16%. And number 8 should have ended up being 84%. Okay, if you need me to, ask questions on Monday, and I can go over any of those that you guys want to. But so here we go. I got a normal curve. What if I want to know the probability of picking a student that's in the top 10%? Well, I'd have to find out what number makes it happen so that this little shaded area right here is, 10%. And so that would make this 90%, wouldn't it? Right? And that's not one of our numbers here. So how do I find that number is my question. Or what if I had a student that had a score of 73 and I want to know what percent is below her score? Would I have to find 73, and that's not one of our magic numbers either. So we could estimate right now, but we wouldn't know. Okay, so we need a method for finding probabilities, and the probability from our conversation yesterday, those are areas. The shaded part is an area under the curve. It represents a probability because this whole thing, all of this area adds up to 1, just like, I'm going to do it one more time here. If I had a discrete random variable, all of these areas would have to add up to 1. All of the shaded area adds up to 1. It represents all of the probabilities from the entire distribution. So we need to be able to find shaded areas which represent probabilities for any x value, not just the convenient ones that are 1, 2, or 3 standard deviations away. So here's the method. I'm going to call this method number 1 because I do have method number 2. I got a trick up my sleeve for later on in the show. We're going to change the x value that we're talking about to a z-score. That's why we brought those up yesterday. We're going to look up the z-score in Table A, which in your book I will show you for the first time on page 379. And then the decimal given from the chart will always be the area to the left. It will always be the area to the left. So I wouldn't be able to get this area from this table. I would get this one. And knowing that it adds up to 1, that's how I figured out this was 90. If this is 10, that's 90, right? Well, when we use this chart, we're always going to get the left side. So I would get 90, and then I would know what the 10 is. Okay, so let me open up to page 379 and show you this chart. You guys are going to want to have a book handy. So when you go in between the next 2 videos, make sure you got your book somewhere close, because we're going to use the Libro today. There's a very important chart in there for you guys to use. Okay, so I'm going to pull out page 379 right here. Okay, this is a weird looking chart, but let's say that I wanted to know this answer. I'm going to go find the z-score. So z is equal to 73 minus 100 over 15. Okay, let's look up 73 minus 100, oopsie, 100, and then divided by 15. The z-score is negative 1.8. Okay, so that means on the standard normal curve, if there's 0 and there's 1, I would be almost 2 standard deviations away, right? Now, if I use the chart, I'm usually finding the area to the left. So here's how the chart works. The z first digit goes right here, 0.1, 0.2, 0.3, 0.4, 0.9, and then the second decimal is here. So I found negative 1.8, and it's not in this chart. This is just a little piece of the chart. So we're going to go all the way to the back of the book, and I'm going to find the whole normal curve chart. See all these charts back here? We've been at the back of the book before looking for random digits. Well, this table A here, these are all shaded areas underneath the normal curve. So we just found negative 1.8, right? It didn't even go a second decimal place. So I'm going to look up negative 1.8 on this chart. You ready? Here's all my negative to 1 decimal place. Negative 1.8 is right here. And then as you go across this row at the top, these are decimal places. This would be the 1.80. And this is for 1.81. And then this next one is 1.82, 1.83, 1.84. But since this only went to 1.8, this is my answer right here. I go to where there's a 0, so 1.80 gives me 0.0359. So this shaded part right here is 0.0359. If somebody did get a 73 on their IQ test, that means only 3.59% of the population is less smart than that person. Okay? Question, what's the probability that I pick a student with an IQ score less than Justin from the page before? Well, Justin had a 112, so I'm going to put x equals 112. That was Justin's score. We changed Justin's score to a z-score. So z ended up being 112 minus 100 over 15. And Justin's z-score ended up being 0.80. Okay, I'm going to go back to that chart and I'm going to look up the probability that's less than Justin's score. Okay, so look, I made a z-score. Once I make z-scores, the mean for z-scores is 1. And we go 1, 2, 3 up and 1, 2, 3 down. The biggest number is 3 and the smallest number is negative 3. So if I want to know Justin's percent of people that are less than him, I go to 0.8, which is not quite at 1 there, and I shade everything to the left. And then I go to my chart, and I'm going to look up, the chart is actually 2 pages, guys, in the back of the book. I printed it out so it'd be easier for us to use here in the video. This is the page I was just on the back of the book. So those are all negatives. If you turn the page in the back of the book, the next page of table A, turn the page, and they're all positive. So you got to know which page to look for. I'm looking for 0.80 this time. Okay, so here we go. Here's 0.1, 2, 3, 4, 5, 6. There's 0.8. And again, this just goes 0.80. So my answer this time is this one, 0.7881. If it had been 0.85, I would go 0.8, and then there's 0.8, 1, 2, 3, 4, 5. So I'd be in this column. So I'd go 0.8 until I got to that column, and it would be 0.8023. Okay, so since this was 0.80, again, my number was 0.7881, and so this answer is 0.7881. So what's the probability I pick a student with an IQ score less than Justin from before? Let me write out the notation. The probability that x is less than Justin's 112 ends up being 0.7881. Okay, he's bigger than the average. And so as a score, so therefore, this number should be bigger than 50%. I hope that makes sense. Okay, this means that 78.81% of the population has scores less than Justin. I hope we're doing okay. Notice the chart on page 379 only has values for positive integers, that first one that I looked at in the book. Go to the back of the book and check out pages. Here's where you find that chart in the back of the book, T1 and T2. You're going to have to use that for your notes here and for homework. So you might as well get a book and take a look at that chart. That's the entire chart of areas for z-scores from the standard normal curve. And again, it's 2 pages long. So the first page you see on page T1 in the back of your book is all negative z-scores. That means you're going to be left of the mean, smaller than the mean. You go to the next page and they're all positive z-scores. That will be right of the mean. And all of these decimals in here are shaded areas to the left of the z-score you're looking up. All right, so notice they're all less than 1. And when I'm at negative 3.4, which would be over 3 standard deviations away to the left, they're real small because there's hardly any shaded area over here. As I get closer and closer to, let's go to negative 1, that's 15.87%. If negative 1 means I'm 1 standard deviation to the left. And didn't we answer that as a question and say that was 16%, around 16% last night? Or let me make it a little more obvious. Keep going this way and I get to the point where I'm at 0. If z-score is at 0, I'm at the mean. And so 50% of data values are less than the mean. I hope that made sense. Let's go to the next page and see what I got going on the next page. Okay, great. So I'm going to walk you through 5 of these. And then I'm going to have you do 5 of them when I take a break and stop the show here, the video, and you'll do 5 of them on your own. All right, I'm going to do number 1, and I'm going to show you how to use the chart to do this. In the first place, look, they're all z-scores. So I don't have Justin's 112 as an IQ score, and then I have to subtract the mean and then divide by the standard deviation. They're already z-scores. So always draw a picture. So I'm going to do number 1. We're going to draw just a real quick sketch. Put 0 in the middle, put 1, 2, 3. I don't even care. You don't even have to put the numbers. Just get a feel for this thing. Negative 1.35. I'm looking for a z that's less than negative 1.35. Okay, here we go. There's negative 1. I'll go past negative 1 and make a line and shade to the left. It doesn't have to be a great drawing, but that's the probability I'm looking for. Since it's shaded to the left, I get to look up the number in the chart. So negative 1.35. Let me bring over my chart here. Hopefully you guys can see this. I'm looking up negative 1.35. Negative 1.35. Well, there's negative 1.3. So I'm in this row, and I'm going to go over until I'm in the 0.5 category. So negative 1.35 is right here. I'm going to circle it because I just printed this out, and I can do anything I want. 0.0885. This answer is 0.0885. What does that mean? That if I did have an IQ score or any other normal distribution where the z-score ended up being negative 1.35, it's definitely well below the mean, and only 8.85% of people would have a score less than yours. Okay, let me do number 2. First thing you should do, draw a normal curve, put a 0, and put 3 marks. Doesn't have to be a great drawing. Now I want less than 2.41. Okay, so that's positive. So I go to 1, 2, almost 2.5, and it's less than, so I'm going to shade almost all of this thing. This answer is going to be much bigger than that, for sure. It's bigger than 50%, and I'm adding a whole lot of area. It might be bigger than 90%, right? So I'm looking for less than 2.41. I go back to my chart. Now these are all the positive numbers, so you got to turn the page and go, those were all negative, sorry. We got to find positive. I'm looking for 2.41, so I look until I get to 2.4. That's 2.40. This right here is 2.41 because that's the 0.01 in the second decimal spot. So it's 0.9920. My answer here is 0.9920. Told you it was more than 90%. You never believe me. Okay, I'm going to skip down to number 5. Look what's different about number 5 is I'm looking for z's that are greater than 0.38. Okay, so there's a 0, and I go 1, 2, 3, and 1, 2, and 3. I'm looking for greater than 0.38, so 0.38 is going to be a little bit to the right, and I'm shading this way. Now, unfortunately, when I look this number up in the table, it's going to give me this white non-shaded area. I want that shaded area. So since the whole thing equals 1, I'm going to find this, and I'm going to go 1 minus this, and I'll get my answer. Okay, let me look up 0.38. Well, those are negatives, so go to the positives. 0.3, and I go over until I'm at 0.38. Now, don't circle stuff in your book. I'll be mad. I'll copy these so you can do this on your own. 0.38 it's 0.6480. 0.6480. But you guys, this part is 0.6480. That's not the part I want. The part I want is over here, and those two have to add up to 1, right? So this is going to be my answer. It's going to go 1 minus 0.6480. So put that in the calculator. 1 minus 0.6480. 1 minus 0.6480. And I get 0.352. If you look at how it's shaded, it should make sense that it's not bigger than 50% because my shaded area doesn't even get to the middle. That number should make more sense. Okay, so I wanted you to see how to do one that's, kind of backwards, where you got to look it up in the chart and then do a 1 minus to get the other side. Now let's do number 8. Look at what is going on here. For number 8, I'm going from negative 2.77 up to negative 1.45. So I don't shade all the way towards the tail. I'm just doing like a chunk of it in the middle. So let me draw it and give you an idea of what we're looking at. So there's a 0. And I go 1, 2, 3 standard deviations up, and 1, 2, 3 standard deviations down. Let me draw negative 2.7. There's 1, there's 2, and 3 is all the way over here. So I'm going to do a line at negative 2.77. Then I'm going to go up to negative 1.45. Okay, well, there's negative 1 and there's 1.5, so that's negative 1.45. You guys, I'm looking for this shaded area that's cut off on the low side by negative 2.77 and on the high side by negative 1.45. Now, how am I going to use the chart for that? Well, always go to the one on the right. I could look up negative 1.45 and get the chart, but it'll be too much, right? I only want this part. The chart will give me all this. Well, then we go look up this number, and it'll give me all this spot, and I'll just subtract it off of that answer. Okay? So the big part, I'm going to do it like this. I'm going to draw it. From there, way over, I'm going to look up negative 1.45. So there's negative 1.4. And negative 1.45, it looks like we were real close to looking that one up before. That's negative 1.45. It's 0.0735. So I'm going to write 0.0735, but that's too much area because that includes all this stuff in this tail, and I don't want that. I only want this. So I'm going to have to subtract something off of that. So look up negative 2.77, and that's what we're going to subtract off. So negative 2.77. Let me go to negative 2.7. And there it is, and I'm going to go over till I'm at this, there we go. Negative 2.77 is 0.0028. So this little guy right here is 0.0028. So if I really do want the area in between these two z values, I got to take this 0.0735, which is too big, subtract the 0.0028, and get my answer. 0.0735 minus 0.0028. Get my calculator. And I go 0.0735 minus 0.0028. And I get 0.0707. That probability is equal to 0.0727. Okay, I'm going to do one more, stop the video, and have you guys try and finish these on your own. I will do them as well, and then I'll put the video back on. You can see the answers. I'm going to do number 9 down here. From negative 2 to negative 2. I think you guys should know the answer here. Yes, you do. So there's 1, there's 2, there's 3, negative 1, negative 2, and negative 3. So I'm going to go up from negative 2, and I'm going to go up from 2, and I'm going to shade this in. And didn't we learn yesterday, the empirical rule suggests that if I'm going from negative 2 to 2, it's approximately 95%. Right? Well, here's what I'm going to do. I'm going to look up the z-score of 2, and that will give me too much. Then I'm going to look up the negative 2 and figure out how much to subtract. Right? So let me look up positive 2. And so here's the z-scores where they're positive. Positive 2.0 is 0.9772 right there. 0.9772. So I have 0.9772 is too much. That's from 2 all the way to the negative infinity, really. And then I'm going to look up negative 2 and see how much I need to subtract. So I find the ones with the negatives, and negative 2 is 0.0228. So I'm going to subtract off 0.0228. It's not going to be exactly 95 because yesterday we said in that definition it's approximately 95. Go look at it. I actually have it right here. I'll go look at it. So 0.9772 minus 0.0228 is 0.9544. Real close to being exactly 95%. Right? Before I turn this off, I'll give you a chance to write that down. Before I turn this off, I'm going to go back to where I gave you the 68, 95, 99.7% rule. Now look at that fat word right there. It's not exactly 95%. It's approximately 95. And it's real close. Wouldn't you say? We just got, what did we get for that? Not 95, but 95.44%. Real close. Okay, here's your job. Right now, I'm going to stop the camera. Find that T1 and T2. There's tables in the back of the book. That's, this normal curve stuff. And I want you to draw, shade, and see if you can get those right. Do that now.